How y'all doing? Now I'm back again with another video. Today I'm going to be showing you two scripts that I wrote to automatically trim the sections of a video out that have frozen frames. Now, if you've seen some of my other videos, you will know I've kind of already shown this off, where you can do this using a ffmpeg filter called mpdecimate. But one of the limitations I expressed about mpdecimate was that it only worked on the video stream. You either have to remove the audio, or if in order for it to use it and for it to kind of make sense. Otherwise, you'll get a video where the audio is like desynced and doesn't make any sense. So I created this because I wanted to have a similar effect, but I actually wanted it to actually be able to keep the audio. Um, I don't have any immediate use for this, but I just figured it was something neat that I could figure out how to do. So that's what I'm going to be talking about today. Before we get started, if you've been enjoying my content and you haven't subscribed yet, be sure to like the video, subscribe. My cat's losing their fucking mind. Come on. And with that, let me show you the goods. So we go over here. They're pissed at each other today. I don't know what the hell's going on. And so this is the script for detecting the sections of the video with frozen frames. If you've seen my video about detecting silence, this looks very similar, with the exception of you can't see because my face is in the way. It looks, but we're operating on the video stream instead of the audio stream. But I'll still go over what's going on here. So I pass in 3 inputs here. First one is the file path to the video I want to do the processing on. Noise is the argument you can pass into the freeze detection to basically decide how much of a difference there can be between one frame to the next before it considers whether it's quote frozen or not. Interesting thing about this that I didn't realize until I was working on this yesterday on a live stream, which is one of the ways that you can pass in the value is a number between 0 and 1, which basically kind of which sort of indicates like the percentage ratio of difference from one frame to the next. And I figured that's how you had to do it. But interestingly enough, you can actually pass in decibels like you can with a silence detection. And I was very confused as to why you could do that. But then I immediately remembered why you probably can, which is because when I was in college, I remember taking a class that was specifically about doing digital image processing. And one of the ways that you could do very efficient image processing is to do this thing where you take the frame and you convert it using some sort of equations to basically a waveform, not dissimilar to an audio waveform, but it represents the image, not audio. And so I'm assuming it's somehow related to that, if I had to guess. The third parameter is the duration. This is pretty much the same behavior as the silence detection. If there is a series of frames long enough where they are too similar, it says, hey, you have frozen frames. You should be known about this. So we're going through the command now. This is, I'm using ffmpeg as usual. Hide banner just hides all that like information it prints out when you first run ffmpeg. So no stats. I didn't use no stats with silence detect. No stats will hide all of that information ffmpeg usually prints out whenever it's processing the video frames. If you pass in no stats, it won't show that. And I didn't want to, because I only wanted the output of whenever it detected frozen frames. Passing in the -an flag to ignore the audio stream because it's not relevant for this. I'm passing in the input, and now we're starting the video filter, and we're using the freeze detect filter. This is what does something similar to silence detect on the audio, but it's looking for a series of frames that are too similar. And I'm setting the I guess you could say the threshold for similarity and the duration. And I'm basically ignoring all the output and the standard error output. And I'm using grep to specifically find the lines that say freeze start and freeze end. Uh, a complication I ran into with this script compared to the silence detection script does was the way the output is formatted is a little different. So uh, the way I had to sort of use this in the Python script to cut the individual video sections out was a little different. So let me actually run this on a video and show you what the output would look like. So if I think I just did this, yeah. So I'm going to use my detect frozen frame script on this test recording I did that is called frozen test. And I'm saying the threshold is negative 60 decibels for like the, I'm assuming it's converting the frame into a waveform to do this comparison. And then one is how long the frames have, there has to be a continuous series of frozen frames for it to be considered frozen frames. I'm gonna run this, and you see it outputs 5, yeah. So there's you see an output for a start duration and an end duration, a second start and end duration, and a last start duration. Now, this is the first time I encountered where there was an odd number of um, like inputs and outputs for start and end. And I actually had to take this into account in the script, and I probably need to retroactively apply this logic to the silence trimming script too, but we'll cross that bridge when we get to it. So now we're going to look at the trim frozen frame script. So this one behaves similar to the way the version 2 of my trim silence script is, where the detect frozen frame script is called from within this Python script via subprocess. Go up here, okay, yeah. So what we're passing in here, we're passing in, again, we're using the MoviePy Python library to do the actual extracting of the subclips and then concatenating them back together and writing out the final file. So we're passing in the file to do the processing on, which would be the same thing that we use to detect the frozen frames on. The file path to write the final processed file out to, and these two would be the same thing that I use for detect frozen frames. I still have my ease logic here for like padding the end of a clip with this ease so the change isn't so abrupt. I don't know if this is actually be relevant with the frozen frame stuff though, because I did it with the silence because the jump between sections of speaking was too abrupt. This might not really, that might not matter, so I might ignore this later. So the generate timestamp function, it looks similar to the same function in the trim silence script. Main difference being it's calling a different script, which is the detect frozen frames, passing in the path to that main video, the noise and the duration. It's calling subprocess, capturing the output, decoding the output as a string. And let's see, so first thing I'm doing is splitting on new lines to get each separate new line. And then I'm kind of trimming off the last entry because there's actually an extra new line after the last output, but it's blank. So I don't want it to mess up my my timestamps, so I just trim it off. And then I loop through those timestamps, and if I split on this the colon, because the left hand side was like all the gobbledygook about like the actual like I guess filter, like what filter was sending out the output, and then the right hand side actually has the information that I want, the timestamp, and then I return it. And then the main function, again, this is fairly similar to the trim silence. I'm counting, I'm tracking the last the timestamp of the end of the last section of what was before was silence. Now it's frozen frames. I call the generate timestamp function to get to the timestamps. I open up the video, get its full duration for doing sanity checks, create an empty list to store the subclips, and I start. And then we are looping over. So this one I had to do a little different. In the silence trimming script, I just kind of had like an infinite loop, and then I manually broke out of whenever I didn't get any when I was out lines to read. This one, so each pair is together. So the value at index 0 and the value at index 1 would be related, because the value at index 0 would be the starting timestamp of the frozen frames, and the value at index 1 would be the ending timestamp. So what we're doing is we're starting at index 0, looping until we get to the last value in the timestamp list, but we're incrementing each time by 2 instead of 1. So what you do is you basically iterate over to the next starting timestamp. So the start of the clip that I want to extract is the timestamp of the end of the last section of frozen frames, so that it knows where to start writing out the next clip. The end is the ending timestamp of this pair, so that's why you'll see that it's grabbing timestamp at I+1. Again, because I said the ending timestamp is wherever you're at index-wise in this loop +1. And then the 2 is this is where the subclip, the end of the current clip is going to be written out to, is this. And I have this ease thing here again, but I think I'm just going to get rid of it. Maybe it's not really relevant for frozen frames. I calculate the duration this clip will be based on when it's supposed to start and how long it's supposed to go. As I mentioned in the trim silence videos, this shit will just straight up crash if the clips are less than a second. This is why I'm calculating the clip duration. If it's less than the minimum duration that I specify at the top, just skip it. Don't write out this section of the clip. Now what this does is, if it skips writing a clip, the last the value that I'm using to know where to start the next clip at doesn't update. So it'll basically kind of keep iterating over until it has enough of a duration for a clip to actually write out. Now this what this actually means is that not all of the frozen frames get dropped, but I find that to just be a limitation of this approach as of right now. The reason why MP decimate this is fine, because you're like it's dropping the frames as it's writing them back out. This is kind of a little different. So I as of right now, I'm just considering it a limitation, this approach. Maybe I can figure it out later. Maybe I don't. Maybe I don't care. We'll cross that bridge when we get to it. Then I use the start and the 2 variables to write out a new subclip. I add it to the list. I update the last variable to be the end of this current section of frozen frames ending timestamp. Increment the count. This is something I need to add to the trim silence script too. If there are no clips, whether that's because they were all too short or there were no timestamps, there's nothing to process, just stop. So this is where I was talking about the number of timestamps start and end being even or odd. So if they're even, I know I have so if it's odd, if the timestamp number is odd, that means the last section of the entire last section of the video was considered frozen frames. So I just don't write out the last section of the whole video. This is why you'll see if was it? So if the timestamp count was even, then I want to write from the end of the last section of frozen frames to the end of the clip. Basically grab the last section of the video into its own clip, and then it'll be concatenated. If it was odd, that means I need to get the last starting timestamp of the frozen frames, and I want to write from the end uh, the end of the last section of frozen frames to the start of this one, and then that's it. What this essentially does is drop the entire end of the video past this last starting timestamp, because apparently it counted the whole thing as frozen frames. Don't know how accurate that is, but it more or less worked when I tried it on a test clip. And then this part's the same, concatenate, write it out, and then you're done. So what does this look like when I ran it on a test? So we're going to look at my, test? The frozen test? Yeah, frozen test. And I think it's like, it's a 10 seconds long? Yes. This is, and this looks familiar. This is like the little Animal Crossing recording I've been using in a lot of other videos. I just took a 10-second, I just grabbed the first 10 seconds of it out to use to process this. Now, let's watch this real fast, and you probably can see a couple times where it looks like nothing's happening. It's like right here, there's a good couple seconds there where nothing happens. And now read the last like 2 seconds or two. Now, I've already processed this, and I will show you what it looks like after it was processed. And I believe it is, what do I call this? It is frozen, I think it's frozen frame out. MPV frozen frame out. I think that's what it was. Yeah, you'll notice that that whole part where it was a setting there, it kind of dropped it. Also, the very end there, whether there was a good kind of pause of about 2 seconds, it didn't have that either. So you'll notice that the duration of this video is 4 seconds, whereas the duration of the original video was 10 seconds. So it dropped about 4 seconds of a video. I might actually be able to run this while I'm recording because it's super short. So this might actually be fine. Let me see, trim frozen frames, yeah. So you'll see it actually print out like where it's grabbing timestamps, and I'll point something out to you. I'm gonna let it run. So it's writing. So something you may have noticed is there was a section of frozen frames between, what was that, 0.1 second and 1.3 seconds. You'll notice when it got to the first clip, it didn't write it out. The reason why I didn't write it out is because the duration was less than 1 second. If it had written it out, it would have crashed. So it skipped over to the next one and basically wrote from the start of the video to the end of that section of frozen frame, or to that section. So the first 4 seconds are fine, and then it drops basically what, about almost 2 seconds, because the next clip starts at, what was that, about right? Yeah. And then it dropped the last like 1.3 seconds of the video, because again, it got picked up as frozen frames. This would have different results depending on what noise I gave it and like what duration of frozen frames. I think the first time I ran this with like, I think like 2 seconds of frozen frames, I think I didn't get anything. I think I didn't get any output at all until I set it to like 1 second. But there you go. This is my attempt at trimming frozen frames automatically while still keeping the audio. Because you will notice if I run this, there was no audio. It's probably hard to hear. Okay. Yeah, there was still audio. It might have been hard to hear. I don't think I had my audio set up right. But anyway, uh, so that's all I got for this video. Um, if it helped out, this is interesting. Drop me a like, subscribe. If you want any clarification of any of this stuff, comment down below. If you want to follow me on other platforms like Twitter and blah blah blah, I got links down below. Uh, if any of this has been helpful to the point that you would like to help support the channel, which would be amazing by the way, I have links down there below for you to do that as well. With that, y'all come on back now, and I'll see you next time.